Good day and welcome to another edition of Synapse NG, where we spotlight scientists whose work is shaping the future of research, public health, and innovation in Africa. I am Dr. Akinbobola Otitoju, and today's episode is centered on one of the most pressing biomedical challenges of our time: malaria, and the emerging generation of Nigerian scientists that are building solutions from the molecular level upward. Our team today is from genes to vaccines, building Nigeria's research capacity in the fight against malaria. Our guest is Joel Paul, an early career biochemist, molecular biologist, research scientist, and laboratory manager in the molecular biology unit department of biochemistry at the University of Jos. He earned his BSc in biochemistry from Bingham University, his MSc from the University of Jos, and is currently pursuing his PhD at the same institution. Joel has strengthened his expertise through certifications from institutions including the African Center of Excellence in Phytomedicine Research and Development and the World Health Organization. He is the principal investigator of one of only 10 projects selected globally for the 2024 Research Capacity Building Grants by the International Society for Infectious Diseases in partnership with the Bill and Melinda Gates Foundation. His project focuses on molecular characterization of a novel Plasmodium falciparum trap-like protein as a potential malaria vaccine candidate. Joel also serves as a mentee on two 2024 Tertiary Education Trust Fund National Research Fund grants, contributing to anti-malaria drug development and biofuel biotechnology. Joel, welcome to Synapse NG. Your research interest focuses on vaccine design using reverse vaccinology to develop region-specific malaria vaccines for the Nigerian population. For our viewers, can you explain what reverse vaccinology is and why it is particularly relevant for malaria control in Nigeria?
Thank you so much for having me. My research interest is centered on vaccine development to address infectious diseases like malaria in Nigeria. This is because vaccination remains one of the most sustainable and cost-effective strategies for long-term malaria control in high-burden settings like ours. To explain reverse vaccinology, I would say it is a genome-based vaccine development approach instead of the traditional method of growing Plasmodium falciparum in a laboratory to identify antigens. We use bioinformatic tools to analyze the entire parasite genome. We computationally predict proteins that are likely to be surface exposed and capable of triggering strong immune responses. And this makes vaccine discovery faster, more precise, and data-driven.
Thank you, Joel. Now, malaria parasite populations vary genetically across regions. How can leveraging local genomic data improve the precision and effectiveness of vaccine candidates designed for the Nigerian populace?
Why reverse vaccinology is particularly relevant for Nigeria is because malaria parasites circulating here are genetically diverse. A vaccine design using global data set may not fully match our local strengths. By integrating Nigerian genomic data, we can identify conserved antigens that remain stable across our parasite population, ensuring better effectiveness within our borders. By leveraging on local genomic data, we can significantly improve vaccine precision by identifying the exact epitope circulating within Nigerian parasite population, By sequencing local isolate, we determine conserved and immunologically relevant regions that the immune system of Nigerians are most likely to encounter. This supports precision medicine or vaccinology, reduces the risk of immune escape, and increases overall vaccine effectiveness.
All right. Now, in practical terms, what are the key steps involved in designing a multi-epitope or target-specific malaria vaccine using bioinformatics tools?
The key steps involved in designing a multi-epitope vaccine are enormous, but most important things to consider are systematic antigen identification, accurate epitope prediction, and rigorous validation. First, genome mapping or mining is performed to identify promising antigen candidates. Next, immunoinformatics are tools used to predict B cells and T cells, and these epitopes are screened for antigenicity, allergenicity, toxicity, and population coverage. Selected epitopes are then assembled into a multi-epitope construct using suitable molecular linkers and sometimes adjuvant sequences. Finally, structural modeling, molecular docking, and immune simulations are conducted in silico before advancing to laboratory validation.
Thank you, Dua. Now, after a successful vaccine design, what next?
After a successful multi-epitope vaccine design, what next is to proceed to experimental validation. This design gene sequence is cloned into an appropriate expression system like E. coli or yeast to produce the recombinant protein. And this is followed by biochemical characterization to confirm structural stability and integrity. Subsequent in vitro testing and preclinical animal studies are conducted to evaluate safety and protective efficacy before progressing towards clinical trials.
Thank you, Joel. Moving on to my next question. What role does interdisciplinary collaboration among molecular biologists, immunologists, bioinformaticians, and clinicians play in advancing vaccine research and development in Nigeria? And where do biochemists fit within this collaborative framework?
Interdisciplinary collaboration is important because vaccine development spans computational design, laboratory validation, immune profiling, and clinical translation. No single discipline can independently complete this pipeline. Molecular biologists handle gene cloning and expression studies. Immunologists evaluate immune responses. Bioinformatics conduct computational modeling and epitope prediction. Clinicians guide clinical relevance and trials implementation. Biochemists fit into all this.
Okay, thank you, Joel. Now, I must say this, that over the years, Nigeria has relied on extremely externally developed vaccines. What strategies can we adopt to encourage and sustain local malaria vaccine development and production?
The strategies Nigeria must adopt for a sustainable local malaria vaccine development and production in Nigeria are: number one, Nigeria must transition from vaccine consumption to vaccine production in order to strengthen our national health security. Um, this will require the strengthening of our biotechnology infrastructure and establishing functional local manufacturing hubs in the country. Also, we would need to expand our genomic data surveillance in the country in order to ensure the availability of locally relevant data for in silico vaccine design. And Nigeria must also encourage the public-private partnerships in order to accelerate the translational research while implementing national policies that prioritize and protect locally developed biological products in the country.
Okay. Now, you are one of the 10 awardees of the 2024 International Society for Infectious Disease in collaboration with the Bill and Melinda Gates Foundation Research Capacity Building Grant for early career researchers in low and lower middle income countries. Congratulations on that grant. Now, what did you do strategically to stand out in such a competitive process?
One of the factors that made me stand out in the past research grants application was my understanding that the application process requires clarity, feasibility, and measurable impact. This understanding helped me assemble the right team of supervisors and presented a well-defined data-driven research plan that addresses local malaria challenge. I was able to demonstrate how the project would build sustainable research capacity in Nigeria and beyond. And this position it not just as a study but as a foundation for a long-term scientific research development in the country.
Here's my second to the last question. Considering the funding challenges that are often faced by young scientists engaged in undergraduate and postgraduate research, what practical advice would you give to help them identify, access, and successfully compete for research grant opportunities?
My advice to the young scientists seeking funding opportunities for their research is that they need to strategically align their work with clearly defined funding priorities. And secondly, that means that they need to develop proposals that have measurable impacts and realistic timelines with detailed budgets. And also, by having the right supervisors for mentorship will help refine their applications and improve competitiveness. And most importantly, persistence is critical as each application process strengthens grant writing skills and strategic positioning. So don't give up, keep trying, and one day you will get there.
Wow, what a wonderful time we've had with you today. Now, finally, for undergraduate and postgraduate students interested in vaccine design, molecular biology, or bioinformatics, what practical steps should they take to build competitive and globally relevant research careers?
For students who want to build a globally competitive career in vaccine design and immunoinformatics, a hybrid skill set is essential. And students should also combine strong laboratory competence with computational proficiencies in tools such as Python and R, and also gaining hands-on experience through internships and specialized workshops in genomics and immunoinformatics is also important. Publishing early, engaging in interdisciplinary collaborations, and continuous developing new skills will enhance global relevance and research impact.
Joel, your story reflects not just personal experience, not just personal excellence, but a broader movement, a generation of Nigerian scientists building global relevance from local laboratories, from vaccine candidate discovery to drug resistance surveillance, and interdisciplinary innovation. Your work exemplifies how research capacity can be strengthened from within. Thank you, Joel, for sharing your journey and insights with us today on Synapse NG.
Thank you so much for this opportunity, and I hope it benefits your audience. Thank you.
Now to our viewers, stay connected to Synapse NG as we continue to amplify African scientific excellence. I am Dr. Akinbobola Otitoju, and until next time, keep advancing in knowledge. Bye for now.